This lab is looking at the molar volume of a gas at STP, and the question we have is, if you have a gas and you have 1 mole of a gas, and you've got this gas under conditions of standard temperature, which is 273 Kelvin, and you've got 1 mole of this gas, and you have enough gas in there to create a pressure of 1 atmosphere, your standard pressure. The question is, if you have so many molecules in here that are creating collisions to create 1 atmosphere of pressure, then what is this volume? Okay, and I think you know already that the volume that we're aiming for is 22.4 liters. That's what we need to find out, is this value, and see how close we can get to it. So how are we going to do this? We know that the ultimate, well, we know the ideal gas law is PV is equal to nRT, but we're not allowed to use R. 22.4 liters, so we don't know R. But what we do know is the ultimate combined gas law. So PV over NT takes all these variables of P and V and N and T and puts them on one side. And we know that if we have one set of conditions for pressure, volume, moles, and temperature, it equals another set of conditions for the same gas in the same situation. So if we actually collect one side of these variables from the lab, we can equate them to the other side of these variables for STP conditions. Okay, so we know that the STP volume is our question mark. That's what we're trying to find. Okay, we know the atmosphere, or the pressure at STP is going to be 1 atmosphere, or 760 torr. We know the temperature is going to be 273 Kelvin at 0 degrees Celsius. And we're looking for 1 mole of a gas, because the question is, what's the molar volume? And so we're talking per mole. Okay, so we know these 3 variables on this side, all right? And we actually need to collect all of this data from the lab. Okay, so that means that in order to collect this data, we need to get the barometric pressure, okay, from the weather station. Okay, we need to get the vapor pressure of water, right? And that means the pressure of the gas that we're collecting is going to be the difference between the two. Okay, Dalton's law, the total pressure, that's the barometric pressure minus the pressure of the water vapor. Okay, we're going to collect the volume of the gas. So if we actually go up to our gas collecting situation setup, we've got the idea that magnesium is going to be reacting with HCl in our container here, and it's producing our hydrogen gas that's bubbling up here. So we've got our hydrogen gas. So again, you have to think then in terms of the volume of the gas that we're getting. So that means that the volume is going to be collected here, and we'll have to make sure that there's no gravity pulling down on that water, so we'll talk about that in the lab. So we've got the volume of our gas, all right, and so that's measured in the gas collecting tube. And then we've got the moles of our gas that we have to get from our limiting reactant, and we have to do the stoichiometry of that. Okay, so that gives us our moles of gas, our volume of gas, barometric pressure minus the water vapor pressure, and then our temperature of our gas from our thermometer. And once we know all of these variables, we can plug them in and we can solve for our molar volume of a gas.